So, hello everyone. We are live now. So, welcome to our webinar to compare configuration management tools, especially in this case, Ansible, Puppet, and SaltStack. My name is Jonas Trüstedt, and I work at ATIX. With me, there's also my colleague Simon Lorenz, who will who will forward me questions if there are any. So in Bright Talk, you have the possibility to ask questions, and I will try to answer them during the talk or at the end of the talk. And today, I will give a short overview on the differences and the similarities between Ansible, Puppet, and SaltStack, including a short demo. So before we start with this, I'd like to introduce ATIX. So ATIX is a company who wants to automate your data center, which means we help with workflows like DevOps processes, and we also help to automate the deployment of new machines, the configuration of machines, the release and patch management. And for all these things, we have several tools we mainly use. So there are the configuration management tools we will talk about today, Puppet, SaltStack, and Ansible. And then we have a lot of container technologies like Docker, Rancher, Kubernetes, OpenShift. We can help you with applications running mainly in containers like Apache Kafka. And we can help you with Terraform, which is a great tool for deployment. And we have our own product, the Ocarino, which is a tool which combines many of these aspects like the deployment, the release and patch management, and it also has a integration for configuration management, and exactly for those tools, Puppet, SaltStack, and Ansible. So if you use one or multiple of those tools and you need an orchestration for your deployments and some release and patch management for your Linux infrastructure, then have a look at Ocarino. It's a great tool. And when we start now to talk about configuration management, the first thing is, why should we use configuration management and what is it? So the why is really easy to answer. It is to automate your configuration, and automation always has several advantages. If you have one way which is always the same way, you can reduce errors. So if you have to configure the same thing on 50 machines by hand, it's more likely that on one machine you make some error. This can be also automated using a bash script, but those tools have also some other advantages. The other thing is why you want to automate things is to have reproducibility. So you want the possibility to create the same configuration again and again and again and again. And even this can be done with bash scripts. But the difference comes if you need idempotence. So this means that you can run your script like 2 or 3 or multiple times, and the result is always the same. This can be done with like bash scripts, but you have to take care that if you run it twice, that it doesn't override anything, which can break things if it was running correct beforehand. And this is something which is built in these tools. So those tools check if your configuration is already the right one. So depending on what kind of thing you configure, like if the package is already installed or your configuration file is already written with those contents you want to have there, then those tools will just skip this step and go on to the next one. So it will only change things if there are any changes. And the last one is infrastructure as code. So I want to have the possibility to manage my complete configuration and my complete infrastructure. So how my servers are configured with the base configuration, with all the applications running there, ideally as code, because this has some additional advantages. And the other thing is, if I do something by hand and I have to follow an instruction step by step by step, usually I can end up with something like this. So I want to build a tent and I followed the instruction, but at some point I started with a wrong corner and my tent is maybe working, but looks not very promising if there will be rain. So the thing is, I want a configuration management where I can simply say, I need a tent, and then run this tool and I get a tent. I can go into it. And if I want to have any changes, like I want a bigger tent, it will adapt this. And so one thing is that I want to describe the state of my configuration, how it should look like, and I do not want to tell my configuration management tool which steps it has to take to arrive there. This should be something the tool should take care of. So at least at until some point. So infrastructure as code means I have one central source of truth. This is usually some kind of version control, which is usually Git. And in this case, I want to have a declarative solution. So as I said before, I want to describe the state I want to have my servers in, or my machines. I want to describe how it should look like in the end, and then there should be some code which magically takes care of everything. The great benefit is I can have a standardized environment. So I say, so these are the rules which apply to every server. And maybe then I have some grouping, like all my web servers should additionally have a certain user with certain permissions. And since I describe everything as code, I want to have it in a way that everyone who is familiar with a Linux operating system should be able to read this code and to understand what it does. And this is why every tool has its own design language, which is more or less complicated, and it always depends on how complex your constructs are. But in the end, the tasks by itself are really easy to understand. And the next thing which is important for infrastructure as code is that you separate your parameters. So everything which is dependent on your infrastructure and your code. So code is this thing which is written in this design language depending on the tool. And this takes care on how to configure things. And on the other side, you have the parameters, and the parameters together with the code merged result in a complete configuration. So in a most easy way, your code says implement a template, and in this template are some variables, and those variables are given in your parameters. So the advantage is that all this code which is used is universal and reusable. So this means you can share your code to configure a certain aspect of your machines with the community, and those can use it, but also can give feedback, or they can extend it by adding some new features. And this is something where the complete open source community benefits from. And in the end, you don't have to put anything which is related to your company, your infrastructure upstream, because this is everything in the parameters, and in the code you have like default parameters, or this code only works if you insert certain parameters. And in the end, you have this centralized structure, and by applying this configuration to your target host, the code and the parameters are merged and are somehow executed on the target host. And how this works is different between those tools. So let me come to the 3 different tools we want to have a look at. So there is Ansible, Puppet, and SaltStack. And if we have a look at the release dates, we see that Puppet is the oldest one and is still a common configuration management tools in IT infrastructure. Then we have Ansible, which was sold to Red Hat in 2015. And since then, it is greatly promoted and has really many users, especially from the Red Hat world. And this means that Ansible is a tool which is very common in many aspects of IT infrastructure. And then we have SaltStack, and SaltStack is maybe the less known of those 3. And SaltStack was acquired by VMware last year. So this means that everyone who used SaltStack Enterprise before has now to switch to a VMware subscription, and VMware integrated SaltStack, so the enterprise SaltStack, into vRealize. The tools itself use still a common programming language. So this is Python for Ansible and SaltStack, and Ruby for Puppet. And then we have the first differences. So how those tools connect to the target host. With Ansible, this is done via SSH. So Ansible pushes the configuration to the target host, and on the target host, in the end, some Python scripts are executed to configure everything. Puppet has a different approach, and Puppet has an agent installed on every system, and this agent asks periodically to the master. So there's one master server, and it asks, how should I be configured? And it sends some information on the host which it's running on, and the master compiles all the configuration, gives it back to the agent, and the agent checks if there are any changes to be performed, and if so, it performs it. And with SaltStack, the great thing is you can have both. So SaltStack has an agent, which is in this case called Minion. And the Minion works very similar like a Puppet agent. So you can run it periodically, and the server itself asks at a master system, how should I be configured, and applies every changes. On the other side, SaltStack is available via SSH. This means I have also the possibility to push my configuration onto the system without having a minion installed on this system. So in this case, SaltStack is more flexible because you have the choice. In the beginning, I said the thing which is important with the code you use is you can share it with the community. And so from my point of view, the community is one of the most important aspects in using those tools, because if you have to start with it, your starting point is a lot easier to start for starting if you have some already ready to deploy code examples for the common use cases. And if we only have a look by numbers, the community, the amount of community modules which are available in Ansible, which is the Ansible Galaxy, it's for around 30,000 roles. And from those are 1,000 collections. So they changed a bit how to share those roles and code things and implemented collections. Puppet, on the other side, has only around 6,800 modules, which sounds much less than Ansible. But we will later have a look at this and maybe explain where those differences come from. And SaltStack, in the end, is again much lower, with only 350 community modules in a formulas repository on GitHub. And then so we already see that there are some differences. And the other thing we have is that those tools have their own naming scheme. So this is something I always explain for those who are already familiar with one of those tools. And they are not exactly the same things for each tool, because there are still some differences. But in the end, there is something which is called facts, which are functions running on your target system, collecting information, which is then used, for example, by the Puppet or the Salt master to identify a certain host system. And all those facts are can again be used to inside of code or parameters to select what things are done or are not done. So they are good for conditions, or to insert them into configuration. Like if you have a network configuration, then you have a fact for your IP address, and maybe you need your IP address and for some configuration of your application. And on the other side, there will be a fact for your operating system. So you have can have a module which is configuring several different Linux distributions. And in this case, where you have to distinguish between like Ubuntu and Red Hat, you can ask if the fact it is a Debian family-based system, then please run this task. And if it is a Red Hat-based system, then please use another thing. And then you have some built-in functions inside Ansible, SaltStack, and Puppet. And in Ansible and Salt, this is called modules, and in Puppet, it is called resources. So those are functions you can use inside your code to describe your configuration. Inside your code, you have then something like tasks in Ansible, or which is I want to use a module to configure a certain thing. So this is something where parameters come into play, and where you have a task like installed packages, or one module would be the package module, and your task could be install the package Apache. And in this case, the task is this thing which is in your code, and it is more easy to use than to write a function which installs packages on every Linux distribution available. And if you have many tasks, you can create a role out of it. And in the end, in Ansible, you run a playbook, which can consist of roles and tasks and some other things. And this playbook is the construct which pushes your code to your target host. And for your parameters, you have your inventory, but not only your inventory. So there's also a structure of variable files for roles, playbooks. And in the end, in Ansible, the inventory is important because in the inventory, you describe to which hosts you want to apply things. So the inventory describes all your systems. In SaltStack, you have something called states, and a state is not exactly the same like a task in Ansible. It's something more similar to a role, or it is a state already consists of multiple tasks. So it's something between playbook and role. And if you have your state already available, consisting of maybe more than one state, and it's universal and available on GitHub, they call it formula. And in the end, you have also something which is like roles, and those are similar to the things in Ansible, and but not always exactly the same. And Puppet and Salt are more similar from the construction view, especially what the things behind those names are. So in Puppet, you can write classes, and one class takes care of a certain configuration and uses multiple resources, so like multiple Ansible tasks, to describe a certain part of your configuration. And if you have a complete set of classes, which can be one or more classes to describe one aspect of your configuration, those are usually modules. And those modules are usually shared by the community. And then you can create roles and profiles for your servers to have a more simplified layer between your parameterization and the combination of different modules, so that you can create something like I have a role for all my base configuration, and I want to implement this role, and this role can consist of several modules. And additionally to the roles, I can describe I have a profile which is like web server, and this web server has a web server role and a base configuration role, and maybe also a user role. So I have several layers for this. And for the parameterization in Salt and in Puppet, there is the possibility to group all my hosts into certain layers. So again, in Puppet, this is called Hiera from hierarchy. So it can have a hierarchy file which applies to every host. I can have a hierarchy file which applies to only certain operating systems or only to certain domains, until I have a hierarchy, and the top layer is always a layer which is only for one a single host, and is basically the name of the host. In SaltStack, I can do a similar thing, but in SaltStack, we have the more complicated thing because we can have this agent way, and we have this SSH way. So in Salt, we have a top file, and this top file states in which groups which roles or formulas are used. Additionally to this top file, we have a file. We have something which is called pillar, and pillar is the structure similar to Hira from Puppet, which contains all those variables and parameters I want to insert there. And I can have different structures, like for all hosts, which are web servers or of a certain operating system. And this works similar as Puppet if I use the agent. So my agent gives back, I'm this host and I belong to the group web services, something like that. And together with the top file and the pillar, Salt can combine it to a configuration. If I use Salt via SSH, I have again something, an additional file which is called roster, and this roster is basically something like the inventory in Ansible. So in the roster, I define which hosts are available to connect by SSH. How are they reachable? So IP address or host name, which user should be used, which SSH key should be used. And so I built something similar like the Ansible inventory additionally to the top file and the pillar. So I hope everyone is confused now. So let me just go over how this works exactly with the different tools. So in Ansible, to repeat this, in Ansible, we have something like the inventory and variable files, and the inventory contains all the hosts I want to apply something to, and maybe also already some variables. Those are combined or override variables which are in this variable file structure. And on the other side, this code part we had in blue beforehand is the playbook, which calls maybe roles or just some tasks. We will see that later in the demo how this looks like. And by combining them, the Ansible host we work on will open an SSH connection to all my target hosts. In this case, it's those 3 green hosts, and pushes some Python scripts over to the hosts to run the configuration. And so Ansible pushes everything to the hosts, and is usually something I run again if I want to upgrade my application or I want to change some parameters. And so it's more like a fire and forget. If we have Puppet, we have those things I said before, the hierarchy for all my parameters, where I said, yeah, I have a file for for all hosts, which is the common file. Maybe I have something which is dependent on my operating system, and I have a hierarchy layer, which is the host itself. And based on your hierarchy definition, the variables of the host can override those of the operating system if they are, if you want to override them. And those can both override those in the common file. And with those, it's easy to create this standardized environment where you can have the possibility to still adapt everything for a single server where you have some extra configurations to make, or your parameters do not fit exactly right out of the box. And on the other side, on your master, you have several modules and maybe a construct of roles and profiles between those modules. And in the hierarchy, you define also on which on your hosts or your different layers, which modules or profiles or roles should be included. And then you have those Puppet agents, which per default run every 30 minutes. So after 30 minutes, the host collects all those facts, like the IP address, operating system, things like that, sends it to the master. The master uses those facts to find the right configuration from the hierarchy, combines it with the modules, and gives everything back to the host. The host itself has Ruby scripts in the end. It's similar like for Ansible, but in this case it's Ruby, and those Ruby scripts take care of all this configuration. And if in this case it's something, if I want to change something in my infrastructure, I have just to adapt a parameter in the hierarchy, and then I can be sure that at least after 30 minutes every host has applied this change. In SaltStack, in this case, it's more the minion or agent design. In this case, it's more or less the same as for Puppet. So I have a top SLS, and the top SLS is more or less the same as we have in Hira for Puppet. And we have the pillars where I have all my variable files. So the top SLS says which state should be applied to the host, and the pillars say for the state and the host one, those parameters should be used. And here we have the same thing or a similar thing like for Puppet, but in SaltStack we have several ways to apply a configuration. So one thing is I have the minion installed on my system, and then I can create a schedule for my minion where all those applications are applied and reapplied or checked, similar to Puppet. But I can also use it like a push use case. Even by using those minions, I can go to the master and say, on those hosts, please run all my states or a certain state. And then the minion is contacted that it should apply this. And if I do not want to have a minion on my system, then I can use the SSH connection to push this configuration to my hosts. And then I need an additional file, the roster, where I define how to reach my hosts. So if we now look at those as to an example of a very simple thing, how to install a new package. If I use it the manual way, I say I use the package manager of my operating system like yum, apt, zipper to install, in this case, NTP. And if I use one of those configuration management tools, they have a resource or a module which is named package. In Ansible, there's a module named package, and if in this case I have a task, and my task has a name to identify what is done, and the module itself has several parameters, and the most simple one is the name of the package I want to install, and this can also be a list, and the state I want to have this package in. And present means I want to have this installed. If I want to have the newest version available, I can put latest inside. If I want to have a certain version installed, I can give a certain version. And if I want to have it not installed, I define the state absent. So it's basically the same in Puppet. However, the Puppet resource looks a bit different. So it's the package resource, and I can give a name, and if I use just the name of the package, I do not have to specify the name of the package again. So I could also name it install NTP and add another line here, name, and then I have this arrow saying NTP, and ensure is the same as state, and I could state latest or present or absent or a certain version. And in SaltStack, I have the name of the thing I want to do as first. So this could be also named install NTP at this point. Then I call my module, which is the module package, and I want to have the function of package installed. And then I only have to state which package I want to have installed, and this is NTP. And again, there's also the possibility to add parameters like latest or a certain version. And in the end, just using one of those tools to install a package shows me that I don't have to take care which operating system I have to use, because this is something the configuration management tools takes care of itself. So this is something where what is a great benefit if you have more than just one operating system on your servers. So let me switch to a short demo, and it's also a real simple demo, but we want to we have one master system, because in this case I use the same system for Ansible, Puppet, and SaltStack, and we have one target system. In the target system, let's write hello.
I think there's some problems with your mic.
Okay, do you hear me now?
Yeah, we hear you, but there is an ugly interruption always. So let's see if it's better now.
I try to, just a moment. I will try to adapt some things. So I hope it's better now. So I will try, I will write hello in my message of the day file. So if we now look at message of the day, it just states hello. And now I will show how to configure message of the day with different configuration management tools. So in this case, we have Ansible and we have an inventory. And this inventory contains, so this is my host, and I don't have any other hosts. I do not have any variables inside there. And I have a playbook, which I will run to this, to apply to this host. And in this case, my playbook says I want to run this on all my hosts. I specify it to, and I want to apply the role message of the day by the user Maniala, which is something which is found on the Ansible Galaxy, because I want to have something where I don't have to write the code myself. And if I now apply this, I run Ansible playbook, give the inventory file and the playbook I want to run. And it says, yeah, we have a template, and we copy this template over to my target host. And if I now have a look at my message of the day, it says, hello, Ansible world, and it has a nice dinosaur inside. And if I now want to configure something away from the default of my of the role I used, I can add some variables. Those can be in the in a variable file structure, or I can add them in the inventory or the playbook itself. So in this case, I want to change this hello to hello, and I want something else than the dinosaur. And I know that there are different templates available because of the documentation of this module. And if I run it now again, it will say, okay, I changed the template again. So we see it changed. If I run it as the second one, it will say the template already was okay. It doesn't have to change anything. So this is what the idempotence means. If I now have a look, it has a great picture of Yoda, and it says, "Hello, Ansible world." And for this, I only need an SSH connection. If I now use Puppet, I have a Puppet environment. And in my Puppet environment, I have the node YAML, so the hierarch file. And my hierarch file says, please insert the message of the day class or apply this message of the day class to my host called demo client. And I overrode the variable what should be written inside this message of the day file. And for this, I have either to wait 30 minutes or can just trigger the Puppet run manually. And so in this case, probably the Puppet run was triggered just some seconds between I run Ansible and I run it. So let me change it again. So if I have a change, so this was a Puppet run which has no change to show. In this case, we have a change, and in this case, it says there's the file message of the day, and there is a diff because they removed the Yoda and added hello world. This is Puppet. So in this case, I could already also say, now let me use the default content, which is provided by the module. And the default content is as well a template. And if we now have a look at this message of the day, this template adds some information about my operating system, the host name, the IP address, the processor, the memory size. And this is something which is already available in the template and is something where those facts I talked about are inserted into the configuration. So if we now have a look at the template, we have this template which is inserted, and it asks the facts of the operating system, the release, the architecture, the host name, and adds everything of those in my message of the day template. So if I want to have some different information, but to implement some facts, I only have to write my own template and roll it out with Puppet. And if I now want to configure everything with Salt, I have the top file for Salt. And it says, yeah, my base group includes the demo client, and I want to include the message of the day. And inside my message of the day, there is also a template used. And I could now, similar to the Puppet, I can run state apply, and it will override the message of the day again. And in this case, it also includes facts like the host name, the kernel, and if we have a look at this template, it looks very similar to the one we have seen for Puppet, with a difference that the thing which was called facts in SaltStack, it's called grains. And on the other thing, we also inserted a variable. The variable is vendor name. And we see that this resulted in ATIX. And to insert a vendor name, we have the information in the pillars. And here we say vendor name is ATIX. But I said that there are different ways to run SaltStack as well. So let me run Puppet again to remove the message of the day by SaltStack. So now it's again the Puppet version. And I could just contact my minion with salt, please run on all hosts, or I could give a certain host like the name demo client or the group base. I can still say state apply. And this will result in exactly the same way I had with a salt call. And these salt calls are also scheduled to run periodically, I think once per hour. And I have the same result. And if I now remove the message of the day again, I can do the same thing via SSH. And in the end, the way it connects is now ignoring the minion, but using the SSH connection. And the only thing I had to add for this is to define a roster where it specify the connection method to this host. And in the end, I already have the same file in my message of the day. So message of the day is probably not a fantastic configuration thing you need to automate on all your servers, but it shows you that you can modify files, for example, configuration files with templates, with variables you can already put in the information you already have on your server, and apply those to your systems and make sure that it stays configured this way. And this can not be used just for configuration files, but also to install packages, to run services, and all these other things. So let me come back to this point. So there was the question if I can show the roster. Sure. The roster is here. So in this case, it's just the name I want to specify it in my top SLS. And then which host is specified for this roster, I could put in the FQDN or the IP address. And I can also specify other things like user, password, SSH key, things like that. But in this case, the default SSH key is already used for the same thing as in Ansible. So now let me come back to the community part. So if we use the Puppet Forge or the Ansible Galaxy to search for certain modules already available in the community, we have a few differences. So if I just use the NTP example, which is a rather boring one, but the standard example, in Puppet, you get like 160 results if you insert NTP in the search for the forge. And you already see that there is a module which is distributed by Puppet Labs themselves, and it's a supported module. You get the information how many downloads are there. There is a quality score, which is basically based on linting. We see which version and when this version was released. And from this, we see other people of the community also write NTP modules. So those can be different on how to perform this configuration, what features are available, how to parameterize my variables. And so there might be use cases to use a different module because maybe it just suits better for your needs. In Ansible, if I just use the Galaxy and run, let's say, NTP, it results in around 50 collections in which an NTP configuration is possible. If I just use NTP roles, I get like 440 roles which can configure NTP. And I get, again, something like a quality score, the number of downloads, and at which time it was last imported. But we see that there are much more. So the difference between Ansible and Ansible Galaxy and Puppet Forge is everyone can put his role or its module upstream and insert it into those tools. But Puppet does more of a cleaning. So it looks which of those modules are deprecated and removes old versions which are not working with the recent versions of Puppet anymore. And this means that there is some cleaning inside the Puppet Forge, which reduces the number of modules. And in Ansible, we have just more people who wrote their own roles without using those from the community. And everyone who made his own role and puts it upstream creates one of those hits in my search. And in SaltStack, if I use for NTP, there are, in the end, since VMware bought SaltStack, there are like 2 Git repositories for formulas, one managed by SaltStack itself and one managed by the Salt community. And this is more or less a fork of the community forked those formulas. But I find only one formula for NTP. This means that in this case, the community works together on one formula instead of having one for each developer who writes his own formula. On the other side, we have a much smaller community for SaltStack, which means this also results in less formulas than like Ansible roles or Puppet modules. If we now look at the use cases where I could use my configuration management, those are different targets. So like I first said, I could configure something like my base configuration of my system, like distribute new users with their SSH keys, with their groups. I want them always to have the same ID on every system. I want to configure operating system-based services like SSH, NTP, the firewall, the sudoers. But this is something I would call base configuration. And then there's the second part, which is I want to install applications and configure them, and I want to roll out changes. And then there's a third one, I want to orchestrate applications. And orchestration means I want to start or stop certain services. And this can be also used to start or stop containers and on certain Docker hosts. And this means I could also use it to administer multiple instances of the same application running on the same host or on different hosts. But they always have the same configuration mechanism, like several Java instances or several Docker containers. But now there's the question, if I want to use configuration management, which of those tools is the right one? And as a consultant, my answer is it depends. And it depends means, yeah, I can't do everything of those things with every tool, so with each of those tools, but they still have some advantages in certain fields. So if I have a look at Ansible, the Ansible advantage is that I can run tasks distributed over several host groups and use this, for example, to install a Kubernetes cluster, something where the ordering is very important. So because first I have to set up the first host, then connect the other hosts which are needed for the control plane, and then to take in all those worker hosts. Ansible is also great to talk to REST APIs, which means I can use Ansible as well to configure my network switches. And for those, often there are already roles available. And since Ansible is very good in this, I push something to my system and it's more this fire and forget principle. This is often used for application deployments and orchestration. This means there are several people who just have like 3 Docker hosts and they use Ansible to define on which host which container is running, because Kubernetes is rather complicated, and for their use case with like 30 containers, it's too difficult to set up a whole Kubernetes cluster. The other great benefit for Ansible is that has a very active and large community, so it's really easy to get help if needed. Then we have Puppet, and Puppet has this advantage that it runs periodically, because with this I can enforce some configuration. If someone changes something by hand, or I change some parameter inside my Git repository, how this should be configured, I can be certain that at least after 30 minutes, every host is configured in the correct way. And the same as for Ansible is that I have a large community with many modules for the most common tools and applications. So like for Ansible and Puppet, it's easy to get a good starting point, because I only have to install it, get this setup running, and insert my parameters. SaltStack, on the other side, is great because I have the choice if I want to run the agent or the SSH connection. So I can also run both at the same time, depending on which target I want to configure. It also has a great integration, which is called Reactor, which is based for which is used for event-based triggering. So I can have a monitoring value like my disk usage, and based on certain limits, I can trigger an event, which can be a webhook, which can be a script which is already local to run, which can be a certain state from the master, which is then called to be applied. So I have really cool mechanisms inside SaltStack. So I have more or less the best of both, like I have for Ansible, from the functions itself, but with a much smaller community. So this means that if I want to really use SaltStack, I have to get into it how to write my own modules on classes or states, because I have some formulas for the most basic things, but those will just be the first steps, and then I have to get into it how to write my own code. So it's more difficult, or it needs more time to implement SaltStack from the beginning. But on the other side, you will have to write your own things if you have your own applications or you have very special needs anyway. And then you can just neglect this smaller community aspect. However, it's also more difficult to get some help for SaltStack. So in summary, configuration management is a really cool thing to automate every configuration of my system, to have one central point where I have this infrastructure as code, where all my configuration is stated in a way that I could read it somehow how to do it. And I have this reproducibility, so the configuration is always the same. If I now want to compare those three tools, we can find many similarities. Every tool has its strength, but in the end, you could already also combine those tools. So we have customers who have like Puppet for the base configuration, and it's used by the operating system department. And then the application department uses Ansible to deploy their application and configure this. So these tools can also be combined, and you don't have to focus on one. But on the other hand, if you combine more than one tool, you have also need to have the knowledge of more than one tool. And in the end, you should support the community, write code that you make available for everyone, because with the feedback and with pull requests, you can improve those modules, and you can participate in this open source community. So I see that we are at the end of our webinar time. So with this, I would like to conclude my webinar talk. And if there aren't any more questions, I think we will be at the end. Simon, are there any more questions?
Well, yes, a really short question. If I would be totally new to configuration management, what would you recommend me? Puppet, Ansible, or SaltStack?
It's difficult to answer, because I think the fastest way to get something running is to use Ansible. On the other side, you really have something running fast, which does not mean that it's best practice, while the language of how SaltStack and Puppet is written more or less enforces you to follow more best practices than Ansible does. So maybe the point on until you can configure something, you can reach this point faster with Ansible to configure something, but to do it a good way, I think it needs the same time for each of those tools.
Okay, great. Thank you very much. So there's no more question.
Okay, so then thank you for your participation, and I hope that the webinar could give you a good insight onto those configuration management tools. And then I hope you have a nice weekend, and see you the next time when we have a webinar. So, bye.